Multiplication of polynomials requires a little bit more work than addition, but it just mainly depends on being able to distribute. We're going to start off by looking at multiplying just monomials. So when we multiply monomials, all we do is multiply the number parts basically together, thinking of the associative property, and then multiply the variable parts together. And so when we look at this, we have 3 times 2, which is 6, and we have x eventually to the third because I have 2 here and a power of 1 there, and we add exponents when the bases are the same. So 6x cubed is what I get. Next example, I'm going to multiply the numbers. Remember, that's a coefficient of -1. So -1 and 4 is -4. And then I have x raised to the 1 here, 3 there, gives me a total of 4. Y raised to the 1 here, 5 there, raised to the 6. So monomials is one chunk times another chunk. You just use the associative property and multiply them accordingly. Multiplying a monomial times any other polynomial, that too we've kind of seen before. So I have a monomial 3 times a binomial x plus 2, and again, you've seen this before. All we got to do is distribute. Mainly involves distribution. So we're going to end up with 3x plus 6. Next example, I'm going to look at this. Let's make it a negative. It's a little bit better. A monomial times a trinomial this time. So again, all we do is distribute into each term, and we end up with a -12. X to the 2 and 3 gives me 5, and a -6. X to the 2 and 1 gives me 3. Negative times negative is a positive 15. X squared. So there's our final product. Multiplying binomial times binomial, you probably remember this from before as FOIL, which stands for first, outer, inner, and last. I don't really look at it that way. I think of it as distribution again when you're looking at two monomials. So you take this first guy x and you distribute it into both. That's going to give you x times x, which is x squared, plus 5x. Once you're done with that, you look at the next term, which is 3, and you distribute that into both of them. That's going to give you 3x plus 15. So all we really did was use distribution, which ends up being first, outer, these two guys, inner, these two guys, and then last. So you can think of it as FOIL if you remember it like that, or just use distribution and then combine like terms, x squared plus 8x plus 15, and we're good to go with that product. Let's look at one more binomial times binomial. So I'm going to distribute first into both, and then I'm going to distribute the second guy into both. That's going to give me 2x raised to the third power, and then plus 3x squared, and then these guys will give me minus 10x, and then the last piece is minus 15. And then I stop and look at this. It is in descending order as I usually would want it. Nothing really combines because I don't have any like terms, so that's the best I can do. Now let's generalize and think of it as just multiplying any polynomial times any other polynomial. And like we said earlier, it depends on distribution. I like writing the smaller one, or the two-term one, the binomial first and then the trinomial. That tells me I'm going to distribute into 3 things. That's going to be 15x to the third plus 6x squared minus 3x. And then I do the exact same thing with the second term, goes and gets multiplied with all of them. That's minus 10x squared minus 4x and a positive 2. Then from here on, I just combine like terms. So 15x cubed is by itself. I've got these guys that give me minus 4x squared. Then I got these guys that gives me negative 7x, and then the plus 2 is all by itself as well. So all we did was, again, use distribution. Now let's look at a trinomial times a trinomial. When I have a trinomial or anything bigger times something else that's even longer, again, I like distributing, but I like putting them underneath each other. Here's what I mean. That gives me 10x to the fourth minus 45x to the third plus 10x squared. Then I have the next piece that comes from distributing the minus x into everybody. I get negative x and 2x squared, that's a negative 2x cubed. Since it's an x cubed, instead of writing it over here, I like writing it underneath. That's going to be negative 2x cubed. Then I have a positive 9x squared. Then I have a negative 2x. And then last piece we're going to do is in green, so this guy will multiply by all three items. 3 times 2 is 6, and that's an x squared, so I'm going to put him under x squared. 6x squared, and then minus 18x, and the last piece is going to be plus 6. So I kind of wrote them in a column underneath each other because that makes adding them easier because now they're aligned properly. So I have 10x to the fourth minus, looks like 47x cubed, and then these guys give me what? 19 and 6 is 25 x squared, and then minus 20x plus 6, and I didn't have to go searching for them because they were all aligned underneath each other. So you could do this or write them next to each other, it's up to you. Okay, let's practice multiplying some of them. I have a binomial times a binomial, so I'm going to do first times both. That's z squared plus a fourth z. Don't let the fractions bother you. Do the same thing. A half times z, or a negative a half times z, is negative a half z. And then negative times positive is negative. 1 times 1 is 1. 2 times 4 is 8. Now I have to combine like terms, which happens right in the middle here, but I have to get a common denominator between the 1/4 and the minus 1/2. Common denominator would be 4, so this guy gets multiplied by 2 over 2, and we end up with 1/4 minus 2/4, which is actually negative 1/4. So that's going to be the coefficient of the z's, or the middle term. So I have minus 1/4 z, and then just carry down the other guys as is. And there's our trinomial of degree 2. Part B, be very careful because a common mistake is saying that that's x squared plus y squared. You can't individually square each piece, so that's a big no-no. What you want to do is you want to look at it as two separate binomials. And once you have it as two separate binomials, you can go ahead and do your distribution or your FOIL. X squared plus xy plus, right here I get yx, but that's the same as xy because the order of the product doesn't matter, plus y squared. And then combine like terms, x squared plus, you have 1xy, you have another 1xy, that gives you a total of 2 of them, xy plus y squared. So again, remember that when you're adding, you just add coefficients, you don't touch the exponents. The only time you add the exponents is when you multiply and they have the same base. Next example, this is a special product, but we'll just go ahead and do it by distribution like we do all the other ones, and you'll notice something happens. X times x is x squared, x times 2y, or negative 2y, is negative 2xy. And then in the middle we get a positive 2xy, and then we get a negative 4y squared. So notice what happens is the middle terms disappear, and we end up with x squared minus 4y squared. That's always going to be the case if you have identical binomials with an opposite sign in the middle. You're always going to have these middle two pieces cancel, and you'll just have the first term squared and the second term squared, always with a minus in between them. Okay, multiply these polynomials. I have a monomial, a binomial, and another binomial. So I can choose any two. I can either focus on these two, or maybe on these two, or maybe on the first and the last. It doesn't matter. I always like focusing on the binomials, and I save this for later. So I'm going to start with the two binomials. Usually less mistakes are made that way. I get x squared plus 3x more distribution, minus 2x minus 6. Combine like terms, that's x squared plus 1x minus 6. So these two binomials gave me this trinomial. Remember this guy I had saved, I have to bring it down now and drop it right in the front of the trinomial. Now I have a monomial times a trinomial, so all I got to do is distribute this guy in. That's 5x cubed plus 5 times 1 is 5, x squared minus 30x. So when you have more than two, it's your choice which two you multiply first. The two binomials, usually less mistakes are made that way if you save the monomial for the end. Okay, given these two functions, f of x and g of x, we're supposed to find f g of 2. If you don't see anything between f and g, there's automatically an invisible multiplication sign. And this 2 really applies to f and to g. So f grabs the 2 and g grabs the 2, and the sign between them is a product, so I look at both pieces. If I put in a 2 for my f function, I get 2 plus 1, which is 3. If I put a 2 in my g function over here, I get 2 minus 2, which actually pops out as 0. And what is the operation I'm supposed to do? I'm supposed to multiply them, so 3 times 0 is 0. In other words, f times g of 2 is 0. Remember, the 2 goes as an input into both of them. So the input of x goes in and an output of y comes out. Now, the second one is the same thing. It's still f times g of x. So x applies to both f, and x also applies to g. So they both pull in the x, and the operation between these two values is multiplication. So f of x, if I don't have a number input, I'm just going to grab the entire function and put it there. G of x, again, if I don't have a number input, I'm just going to grab the whole function and put it there. Now I'm going to multiply them. So if I have two binomials, I better enclose them in parentheses. Then I go about my business and I distribute. That gives me x squared minus 2x plus 1x minus 2. Combine like terms, x squared minus 1x when I combine the negative 2 and the 1 minus 2. And there's our product function, f times g of x. Again, this is the global one for all x's. This is the one instant for the x value of 2. So if I check and I put a 2 in here, that's going to give me 2 squared minus 2 minus 2, which is 4 minus 4, which is the 0 I had gotten here. So this is the global function, the product of the two functions for all possible x values, whatever they give me. This is the product function only for the input of 2.